When organizations look to cloud, they are often inspired by the achievements of digital native competitors who have built their products in the cloud from the start. As a result, objectives for cloud adoption are typically go faster by increasing the productivity of developers and so reducing the time to deliver products. Save money by using pay-per-use infrastructure or reduce operational overhead with managed services. Do more and innovate by taking advantage of global scale or specialized services like AI and ML. However, all clouds are distributed systems made up of commodity hardware in shared data centers. Unlike on-prem, there is no optimized redundant hardware. You are renting resources by the minute but paying a premium for the privilege. There is no castle wall around the outside. Ultimately, everything is shared. Consequently, organizations that opt to host applications built for on-prem in the cloud will likely end up with less reliable, more expensive, and less secure systems. While cloud-hosted is the where, cloud-native is the how. It is a style of software architecture that sets out to make the most of the capabilities of the cloud and overcome its limitations. Cloud-native is about creating efficient and secure systems that are more reliable than the infrastructure they run on. While traditional architecture treats change, failure, and security threats as exceptions, cloud-native treats them as the norm. Cloud-native applications are made up of small, loosely coupled components. Loose coupling means that components of a system are not tied together so that they can change independently. This is where most of the developer productivity comes from. Failures in loosely coupled systems are isolated, meaning that if a component fails, it does not bring the whole system down. Similarly, components scale independently, providing extra capacity only where and when needed. This is how resilience and cost savings are achieved. With these extra components comes added complexity. This means building in observability and manageability are also vital principles. The system's state should always be visible and managed so that problems are, ideally, automatically corrected. Cloud-native systems declare the desired state, and the cloud seeks to achieve it. This again ensures reliability and reduces operational costs. The final principle is zero trust. As security cannot be guaranteed, all communication between components must be authenticated and secured. All data, both in flight and at rest, must be encrypted. These are the principles that characterize a cloud-native approach. Another vital aspect is choosing an appropriate level of abstraction. Whether tying a system to a single cloud to prioritize optimization or allowing an easy transition to another cloud by prioritizing portability depends on the use case. All cloud vendors provide a wide selection of tools. For cloud-native to be successful at scale, it is essential to curate these in a way that supports the implied objectives of productivity, efficiency, and security. I like to think of a cloud-native platform as assembling tools to provide three facilities. A laboratory, prioritizing productivity, a safe, friction-free environment to experiment and get rapid feedback using a comprehensive toolkit. A factory, prioritizing efficiency, an automated process that takes the output from the laboratory, assembles and thoroughly tests it, so it is certified and ready for deployment. A citadel, prioritizing security, an environment to run the application securely and reliably, fortified from attack. To be successful at scale, all three of these need to be in place to support cloud-native development. To summarize, cloud is the where, but it has constraints and limitations that must be overcome. In the cloud, change, failure, and security threats become expectations, not exceptions. Cloud-native is the how, an architectural style that unlocks the full potential of the cloud. Cloud-native success at scale requires a cloud platform prioritizing productivity, efficiency, and security. Cloud provides the potential to go faster, save money and do more, but it is by using a cloud-native approach that these objectives are most likely realized.